Okay, so welcome back. Now let's do some examples where we're going to use the inverse property of these functions. So the first thing we need to do is, again, make sure you understand the domain of these things. Okay, so again, in this case here, the domain of this function, right, is going to be controlled by the domain of the inside function, right? So it's got to be, in order to get, so the domain of this function is a negative 1 to 1, right? The domain of this function is negative pi over 2 to positive pi over 2, okay? So this here is going to control what the domain is. Okay, so this is negative pi over 2 to positive pi over 2. Okay? Okay, and so that's what we have to do. So when we have this composition, the domain, and so I'm going to write it right here for both of them. I'll write it here in between. So we know the domain is going to be negative pi over 2 to pi over 2. Now for cosine inverse with cosine, again, the cosine function has a domain that we're restricting to what? 0 to pi. Okay? The inverse cosine domain is what? Negative 1 to 1. And so again, the domain that's controlling this is going to be zero to pi. Okay, so just keep that in mind. Okay, and you can reason through it just by looking at the domain of the inside function compared to the domain of the outside function. Okay, so now that we got these domains for these composition functions, then let's see what we get. So now we look at the angle, and so we ask ourselves, is this angle inside this domain? If it fits in here, then yes, we can go right to the answer because the inverse property just says we get x out. So in this case here, the answer is pi over 3. Now, here we can see that 2 pi over 3 is not in the restricted domain. But what we can use is we know that sine of 2 pi over 3 is equal to the sine of pi over 3 because it's symmetric about the axis of symmetry at the maximum. And so we know that there's a maximum point at sine of pi over 2, right? And so we know that this sine of this angle and the sine of this angle is going to give us the same answer. Also the reference angle, right? So this is in the first quadrant, this is in the second quadrant, okay? So we know that the reference angle for this is the same as the reference angle for this because this is 60 degrees, this is 120 degrees, which puts you at a reference angle of 60 degrees in the second quadrant. So what does that mean? It means that these are going to be equal. So that means I can go ahead and say that sine inverse of sine of pi over 3, right, of this composition is the same as this composition, and so we can say that this is equal to pi over 3. Okay. Now let's look at cosine. Now cosine, the restricted domain is going to be 0 to pi in this case. So now we look at the angles. This angle is in this interval. So we can just go right to using the identity property, and this is going to give us 2 pi over 3 because it is within the domain. Now this is not in the domain, but notice that this is in the 4th quadrant. Okay, so it has a reference angle of 60 degrees, but it's negative 60 degrees. Okay, and so we know that the cosine of negative pi over 3 is going to be equal to the cosine of 2 pi over 3. Or excuse me, pi over 3 is what I meant. Because this reference angle is the same as the reference angle in the 1st quadrant. Okay, and why? Because if you look at the right triangles for the first and 4th quadrant, they give you the same value. Remember, it's adjacent over hypotenuse. So cosine is the same sign in the 1st and 4th quadrant. So that means that this is going to be equal to cosine inverse of cosine of positive pi over 3. And so this is equal to pi over 3. Okay? So again, all I did was use the fact that these two are equal. And now that I have an angle that's within the restricted domain, I can now apply the inverse property and get my answer. So again, main thing is make sure you understand what the domain is for the composition of functions. And then once you know that, then you just got to use either checking to see if it's inside the restricted domain. If it is, then you just go use your inverse property. If the angle is not in the domain, then you got to find an angle that is in the domain that gives you the same result, like we did here. Okay, cosine of negative pi over 3 is the same as cosine of positive pi over 3. Sine of 2 pi over 3 is the same as sine of pi over 3. That's it. Have a great day.